In the class. You don't know.
They're 25 minutes.
They're about 25 minutes, unfortunately, but
You should know that.
I should try to edit it, but I don't have time. Maybe I'll give to my TA, Karsten. You can edit.
Yeah.
All right, implicit differentiation, like everything we've done so far, I love this stuff. Okay, we have been doing what's called explicit differentiation, not to be confused with parental discretion advised because of explicit JK. So what you do when you're doing explicit differentiation is one of the variables, or one of two variables, you always have two variables, x and y, has been explicitly given in terms of the other. Meaning one of them has been solved for y. Solved for y. That's what we've been doing. I've just given you all the functions. If you've noticed, everything has been y equals, or that's what you would solve it for y and then take the derivative of it. It was just so nice and easy for you. Well, unfortunately, not every equation in math can look at that pretty, okay? So what they had to do is create what's called implicit differentiation. So implicit differentiation, and again, if you don't remember what the word differentiation is, it's just the process of taking a derivative. Implicit differentiation would be used for like an example like this, like x squared plus 2y cubed minus 4y equals 2, something like that. Like that is really hard to solve that equation for y. You can't get y by itself, to be honest with you. If you try to get y by itself, you get y on the other side. So it would be much difficult to try to just solve for y and then take the derivative. So they had to, like I said, do something else. So when the equation looks really complicated, then we do implicit. And so tonight's homework, the first question you're going to do, you're going to be like, can I just do this the old way? Yes. If you can do it the old way, do it the old way. But if you can't, then you've got to try it the implicit way. Okay? So when the equation is too difficult to express y as a function of x explicitly. Okay. When the equation is too difficult to express y as a function of x explicitly. All right. So let's actually take a derivative. Move this up here. There we go. I have 7 examples, but really I have 3 major ones, and then 4 of them are really quick and easy, which you're going to see in a minute. Derive x cubed plus y cubed equals 5. Now, I'll be honest with you, you could solve this one implicitly. Take the cube root of y on both sides, and you could do it. Okay, but we are actually going to derive it implicitly. Okay. So here's the first thing you need to understand, and I'll write this down. You need to treat y as a function of x. Okay? Well, what does that mean? That means when you take the derivative of y, you take it as if it were an x. Okay? So you take the derivative, or you derive both sides. I know. With respect to x. Now, this is what the other class did not understand, this whole with respect to x. Well, what does that mean? Well, it means you're taking the derivative as if it were an x, but the problem is we're taking the derivative of y as if it were an x. So we have to do something extra. So do you remember with the chain rule when we took the derivative of u? What did we attach always next to it? U prime, because we were respecting the u as if it were an x. So we'd have to attach the chain, or the extra derivative part, okay? So we're going to take the derivative of y just as if it was an x, but we're going to attach something onto it. And what that attachment is, we're going to actually not, you could call it y prime. In the past, I've had students call it y prime, but unfortunately to me, that looks like y to the 1 sometimes. So I actually changed notation on you this time. So here's what I want you to do. Every time you take a derivative of y, attach dy dx. Every time you take a derivative of y, just attach right next to it dy dx, which is like the chain, okay? So don't call it y prime. I mean, like I said, you could. I remember people in the past have done it like that. They're like, can I just call it y prime? I'm like, oh, sure, but it looks like y to the 1 for me, so I kind of try not to do it. All right, so here's some steps. Let's try this, okay? So if I said, all right, just take the derivative of x cubed, what would you say it is? You know it. 3x squared. Do I have to attach anything extra? No, because that's what we're used to doing. We've always taken derivatives with respect to x, okay? And it don't have to do anything. But this one, take it as if it were an x. What would y cubed be? 3y squared. But because you took a derivative of y, attach dy dx, which we've been used to calling the chain. Just attach right next to it. Just right next to it, write dy dx. Equals, and then this is a part everybody always forgets. You have to take the derivative of both sides, everything. What's the derivative of 5? 0. Okay? Everybody forgets that. They'll put 5 right there and they'll totally screw up the whole problem. All right, so now that you've done that, then it's very easy. Just solve for dy dx. That's the slope. Dy dx is your derivative. That's the slope. Solve for dy dx. So this one's pretty simple. What do you just do? What do you minus over? So 3y squared dy dx equals negative 3x squared. Divide by 3y squared. Divide by 3y squared. Dy over dx equals, what does that reduce to? Okay, so now here's the thing. This is the slope function for a derivative. For this derivative, this right here, okay? The only thing extra that you're not used to is you have a y value in here. So if I asked you to find the slope at a particular point, no longer do you just plug in x, what else do you have to plug in? That's why. That's really the new thing. Okay, you don't just plug in x anymore. Now you plug in an x and a y. You have to know both points. So they're going to give that to you. How do you feel? Do you feel good? Feel good?
I like the DYDX. It kind of looks easier.
It does. It's going to look really crazy messy, but you're going to look so smart when we do the last problem. Last problem is like challenge problem galore. So much fun. All right, let's do another one. And then let's just quickly do some easy ones and then get ourselves to the hard one because that's really what we're here for, kids. Find the dy dx of 2x plus y equals x minus 5y equals 1. By the way, you have a problem on homework tonight like this. Number 12 is like this. I'm going to show you 2 ways to do this problem. I'm going to show you the way you used to do it before we learned this and the way we're going to do it as if we learned it this way. Same thing, okay? For those of you who don't know how to solve right now for y, you should put this over 1. You should cross multiply. And you would have 2x plus y equals x minus 5y. Do you all agree, right? That's how you get it out? All right, let's do it the old way. Let's just solve this for y. Solve this equation right now for y. What would you have? Add 5y over. So 6y equals negative x. Y equals negative x over 6 or 1/6 x. Do you all agree? Okay. If you took the derivative of this side, what would that be? Negative 1/6. If you took the derivative of y, the derivative of y is y prime or, wait for it, dy dx. Every time you take the derivative of y, it's dy dx, yes, because that's what we call it. So there we go. Negative 1/6. That was nice. That one worked out to an actual full value. Let me show you, though, the new way of doing it. 2x plus y equals x minus 5y. Okay, ready? What's the derivative of 2x? 2. What's the derivative of y? 1 times dy dx. Correct. You don't have to write the 1. I just am doing that. You all agree, right? The derivative of y is dy dx. Equals, what's the derivative of x? 1. What's the derivative of negative 5y? Negative 5 dy dx. Every time you take the derivative of dy dx, y, you take dy dx.
I look so smart.
Now put all your dy dx's on one side. Well, this is cool. We can actually add these together. This would be 6 dy dx minus the 2 would be negative 1. Oh, wait for it. Look. It will give you the same answer, y'all.
No way.
Okay? Now, this happened to be that you didn't have any y's left in the problem. It both gave you the same answer, but they are the same thing. It's the same process every single time. So, coolness. All right. Let's finish this up because I really want to get the hard one, which is the best part. Differentiate with respect to x, meaning as if it was an x. However, since it's not an x, you have to do something. We'll call this 3, 4, 5. I'm about to blow your mind on one of these. Can't wait. I just can't wait for it. There we go. All right. These are quick ones. We'll get through this and then you'll be so amazed. Differentiate with respect to x. So if it is an x, you take the derivative of it. But if it has a y, you've got to attach dy dx. Have to. We have to. It's just part of it. So what would the derivative of this guy be?
14x.
Just 14x, right? Nothing fancy. We can do that one. Simple. But what would the derivative of this one be? Correct. Okay. And by the way, we're not solving. I didn't say to set this equal to anything. We're just, this is it. I'm just trying to do quick here. All right, let's look at this one. This has x's and y's mixed in it. So if I said take the derivative of this x, you would say what? 1 plus, what's the derivative of 3y though? 3 dy dx. That is the answer. That is the derivative of that one. What about this last one?
You're insane.
It's insane.
I hate you, Jack. Out.
Guys, when you have x's and y's being multiplied together, you have to do product rule. That was like when we had the u's mixed with the x's on the last one and we had to do product. It's the same thing.
The last one? What?
The last test, when we had u's mixed with x's, we had to do product rule, that really hard chain rule with product rule. No. So let's do this. Product rule says first times the derivative of the second. What's the derivative of y squared? Be careful. 2y dy dx. Okay? And unfortunately, many students are going to stop here and be like, I'm done. Is that how the product rule ends?
No,
Plus. Second. Do I have to add dy dx though?
No.
Why no? Didn't take a derivative. Times what's the derivative first? 1. So you can do it. I tell the students always because you're going to have to clean this up on the next one. You'll see it's going to get nasty. X times 2y dy dx. Another way to write that is I always write alphabetically. 2xy dy dx. And then this one I would just 1 times anything is anything. And so that is actually the answer right there for that one. Okay. Are you ready?
Let's go.
If you can get this one.
Go back.
Okay. If you can, yes, I'm sorry.
X is 0. Okay, I missed number 10. No. For the last one, I did. He said I need this. I need that grade.
I'll do 1 minute, Jed. Let's get this done first, honey. Susie, you're not even here, and look at what I have to deal with.
Look at that crazy.
Find the slope value of y cubed plus y squared minus 5xy squared minus x squared equals -4 at the point 1, -6 precious lambs. Are you ready? You will look back at this and be like, I'm in beast mode derivative right now. I'm so good at this, okay? You ready? Take a derivative of y, attach dy dx. That is really the main point of this whole thing here. So we'll start, and now what? By the way, I'm going to start all the way in the end because this is going to get pretty long. What is the derivative of y cubed?
3y squared dx.
Good job. Plus, what is the derivative of y squared?
2y dx.
What is the derivative of negative 5xy squared?
Product roll time.
Exactly. Exactly. This is a product right here. It's product rule within this problem. So I have to just kind of pause and start doing product rule before I keep going.
It kind of stinks.
It doesn't. It does not. It's
Awful.
beast.
Negative.
Okay, now here's what I do. I do this and this. This is how I make my product. I include the sign, by the way. Okay, so negative 5x and then the y squared. So let's go through the product rule right now. First would be negative 5x times what's the derivative of y squared? 2y dy dx. So first times derivative of the second plus second, which is y squared, times what's the derivative of negative 5x?
I can't see. Next. This isn't fair.
Yes or no, are you in agreement with what I just did?
Yes.
Okay.
I'm in agreement, but I'm
Am I done?
testing.
What do I have to do now?
You have
Everything
combine
else.
all.
No, I haven't even, can't count them yet. Have I even finished taking derivatives?
Alright. 4, you got
What's the derivative of now this one?
negative 2x.
Negative 2x
You're on the other side.
equals 0. I cannot stress this enough. A lot of students forget this right here. Please, it's 0 when it's just a number. All right, now, can I, just before we begin, and I know you all don't like this, but cleaning up really will help you out. Here's what I mean. 3y squared dy dx plus 2y dy dx. See this right here? You can actually put all that together, but I would put it together like as a monomial and in correct alphabetical order. So what I mean is, what's negative 5x times 2y dy dx? What's another way to write that?
Negative 10 y dy.
Yes, okay. There's reasons for this. See this right here? I don't like the way that's written either. I would call that negative 5y squared minus 2x. Do y'all see what I'm doing here? Cleaning it up actually will save you. You'll see why. Now, step number 3 is to get all your dy dx's on one side and move everything else over. So anything that doesn't have a dy dx,
Get it out.
these two right here, move it to the other side. So 3y squared dy dx plus 2y dy dx. I'm actually writing this for no reason because you'll probably all skip this step right here. Equals 2x plus 5y squared. Agreed? Okay, now, what do you remember? How do we get dy dx by itself?
Take it down.
You factor it out. And what are you left with?
5y squared.
They got polynomial.
3y squared plus 2y minus 10xy equals 2x plus 5y squared. And then how do I solve for dy dx? I just divide that out. Dude, look at how cool this looks. But we're not even done. Let me tell you why. This is the derivative formula.
Like both of them.
Because now, normally you would just plug one value in,
Not here.
but you have to plug, because you have x's and y's mixed together, both of them in.
Wait.
But wait. So everywhere you see an x, you're going to put 1, and everywhere you see a y, you're going to put negative 6. So this is 2 times 1 plus 5 times negative 6 squared over 3 times negative 6 squared plus 2 times negative 6 minus 10 times 1 times negative 6. And for the sake of time, the answer is 7/6.
Let's go. 7/6.
Y'all, look at that.
We're geniuses.
Look at that beautiful thing.
How was that beautiful?
If you can do that, that is what we consider a harder version of implicit differentiation. But if you can do that, tonight homework will be cake for you.
Order?
Okay? Page 152.
You picked a bad day to not.
1 through 19 odd. You let her know that. She's gonna have to watch this video. That's all.
We have like
She's gonna be
5
kicking
problems like the last time we had one.
Now listen, do you always have to do it this way? No. You can do,